Boys and girls, today I come up with one more program based on recursive function. Recursive function, what does it do? You are going to find out a to the power of b, right? There is a built-in function called as math.pow, and here also we have written a function called as pow only. Mind you, boys and girls, when we have a ready-made function, math.a, b means it will find a to the power of b, as simple as that. Why would you write here? When there is a existing ready-made function, why should we go in for such type of function? That may be the doubt lingering in your mind. But here, my main intention is to explain the concept of a recursive, right? A to the power of b means a has to be multiplied for b number of times. When I write 2 to the power of 9 means 2 into 2 into 2 into 2 into 2 into 9 times you multiply, whose answer would be 512. 2, 4, 8, 16, 32, 64, 128, 256 and 512. For example again, you can give any number. When you give the number, see to that it's not such a big number, but despite I have given 3 variables a, b and result. All the 3 of them not as an integer but as a long integers. Right? I am going to explain to you. What concept did I use it? There are 2 methods again. One is called as main method. The first method in this program called as power rack. The class name is called as what? Power rack. There are 2 methods again. The first method is called as main method. The second method is called as POW, shortest form of power. Right? What do I do? Here, I take the value of A and I take the value of B. So I take these 2 values, right? A will be multiplied for B number of times, and whose result will be stored in result and display the result. That is what exactly I am doing here. Right? That is what precisely I am doing here. Now let's see what happens. Right? Now, in the main method, I create an object called as INP with the help of 3 built-in classes which we have been doing right from class 9, 10, 11, 12. Buffered reader, input stream reader. I am using these 2 built-in classes which are there under the package called as java.io, input output stream. I create an object called as what? INP. Right? With the help of INP, I use a built-in function called as read line. This read line, see, INP.readLine means here I create an object. This will be taken as a string. Read line will be taken as a string. That string I convert into parse long. Long.parse means this string will be converted into the content of the, though you are going to give as an integer, that will be treated as a string. That string gets converted into long number that will be stored in A. The first number is A. The second number would be B. Right? Once if you accept the value of A and B, what do I do is, from main method, this is where the main method is. From main method, I switch the control to a method called as POW, where the value of A and B I substitute here. I create an object called as OBJ. What the class name is? Power rack. Power rack. OBJ is equal to new power. This is the first object for the sake of input. This is the second object to navigate from main method to the power function. Right? What do I do here? Please note obj dot POW A, B. From here it goes to power, whatever may be the values returned, that will be stored in result, and you are going to display that result here. A to the power of B is RAS, which is RAS is here. Now please note, this is where you need to pay attention. Whole of class 10, 11 and 12, you have the habit of using math.pow. Means you are using the built-in function. Here I am not using the built-in function, we the users define a function. That's why it's called as user-defined function. That's why it's called as user-defined function. What I do is, from main method, I go to a method called as POW, where the A value will be stored in M and B value will be stored in N. If N value happens to be 1, you return the M. Else, this is the crucial statement. What do I do? If I give A values 2 and B value as 9, what does it mean? 2 to the power of 9, which is 512. We are not bothered about the output at all. Let's not bother about the output, boys and girls. What I intend to do, how does it work? Let's see that. What is the value of A is 2. What is the value of B is 9. So this is the actual parameters 2 and 9. When you send A value will be stored in M, B value will be stored in N. This is called as actual parameter. So this M value will be 2 and N value will be 9. 9 and 1 are they same? No, comes down. M value is what? M value is 2. 2 into, again it goes 2 to the power of 9 minus 1 will be 8. Right? We are going to keep doing it. 8. 8 minus 1, 7. 7 minus 1, 6. 6 minus 1. So 2 into 2 into 2 into 2 into 2 into 2 till you get N value as 1. The moment N value is 1, you return it. Okay? As you say, 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. 16 into 2 is 32. 32 into 2 is 64. 64 into 2 is 128. 128 into 2 is 256, 256 into 2 is 5112. Right. So this is the one, again it is in back now. How long will it do till it just one moment you do this one, the value of M gets returned. M what does it do? Recurring multiplication will be keep taking place. Recurring multiplication will be keep taking place. First 2 into 2. Then 2 into 2. 2 into 2 is how many times you do it? 9, right? Come on. 9, 8, 7. This multiplication will be keep doing it. When you return it comes here, that will be stored in result. So such a order printer A value is what? 2 to the power of 9, because B value is 9 is, what is the result value is 512. That's all. You print it. You can give any value. I use a block called as try catch finally. Here I am not using the keyword called as finally because only one block is there, only one scope is there. Try catch finally. There are 3 keywords are there. These are all known as error trap routines. Because we are going to give the value of A, B, right? At the time of input, both of them A and B are called as long values. A and B are called as long values. Other than this, when you try to input it, so error gets trapped. That will be stored in a variable called as E. That error code you are going to display. So this portion is called as error trap routine. What do you mean by that? That we have a built-in function. What happens is, we the users validate the data. Validate means when he's asking the long value, we are expected to give the long value. So I take the value of A and I take the value of B. See to that, if you try to give a character, if you try to give a string, so the error will be captured. That will be stored in E, exception. Okay, and you display the E. That error code will be displayed because the input what has been given is wrong. That wrong error code will be displayed. That is the reason we use always the try, catch, finally, routine. In short, we call error trap routine. Boys and girls, you stop this video, copy down this, practice this program. Okay, practice this program in next class. In fact, I intend to do one more program also. Right? I intend to do one more program. Okay, probably next class we will do 2 programs. Okay, then we'll wind up this. Then we'll go to the another 4 more programs are required in this chapter. Right? 4 programs we shall write. Besides this, another 4 more programs we will write. Convert the given decimal into binary. Convert the given number into numbers into words. That is figure to word conversion. When I give 1 6, your program should write not 16, 1 6. If I give 4 2 9. The answer should be 4 2 9. I give as an input as digit, but your program will be doing in words. FOUR, TWO, NINE. It extract the digits, it will translate into equivalent words. So that is called as figure to word conversion. We will do it. Converting the decimal into binary, decimal into octal, decimal into hexadecimal. So these 4 programs we shall do in the following class. Okay, I repeat again, copy down this and practice it. Okay, take care boys and girls. Bye bye. Here is the second program, boys and girls. Second program on recursive. Second program on recursive. What does this program do? This program would take 2 values, namely P and Q. Take 2 values, send it across to a method called as GCD. Basically, this GCD function or HCF function, these days we call GCD, greatest common divisor. Formerly it was called as HCF, highest common factor, matter is same. Why am I using this word? I still remember in the year 2009 batch, we have done this program with the help of a GCD. Same ditto, but in the board examination, instead of using the term GCD, they have used the term HCF. Almost all of them, except 1 or 2, most of them got completely puzzled. It's unheard, they never heard about the term called as HCF. HCF means highest common factor. Highest common factor or greatest common divisor is one and the same. So that's the reason I am using both the terms. They may call it as a HCF or they may call it as a GCD. Matter is same. Matter is same. Here I go. What does it do? There are 2 methods again. One is called as main method, another is called as GCD. I create an object with the help of the object. If there is a static edge, object need not be created at all. Both of them happens to be the static function. The moment you use the keyword static, right, you need not to create the object cross. Straight away, without creating this object, you can say, you can strike it up this, you can strike it up all the 4 of them. Automatically it will go there. But better I do like this. I take away this keyword called the static. I take away the keyword called the static. Even if you write this, no errors will be found. Your program will be error free. But you should know the concept of creating the object which you have learned in class 9 itself. With the help of the object, from main method you go to the method called as GCD. What is the value of P would be? 216. What is the value of Q would be? 24. Right? F. What are the q values? 24. 24 and 0 are the same? No. What happens is this will be divided. What do you do? What do you have this? Q value will be 24. 24 divided by, first of all, what do you do? The long division method is 216 divided by 24. When you do it, what happens is, right. Right? When you do it, what happens is the remainder will be 4. The remainder will be 2. Right or not? Again, this has to be, this process will be continued, 192. Then this process will be continued, the last value will be, so this is the one which will be, if as long as q value is not equal to 0, again it will go back here, the q value will be substituted, and the remainder of model is going to, it's not division, remainder of, this remainder only you take, no? This remainder again divided. This process will be continued till you get q value as 0. The moment you get a q value as 0, sometimes you don't get 0 also, less than 0 if you get 0, because it's an integer value, any fractional part will be truncated. The moment it attains 0, the value will be returned, right? Here there is no output, look at here, there is no output. In fact, we should print the output of here. See, this is how it should be done. This is how system dot out dot print ln, what will be the value will be? Okay. GCD or HCF of what the value is? What value did we give? Similarly this also. It goes there, it will find the value and it will get returned. That's all. Same thing here also. Otherwise, if you do there, you will not have the output. System dot out dot print ln, what do you get? GCD or HCF of what value we want to give? Let's say that 1440, right? You can use some other set of values. System dot out dot print ln, two values will be substituted, whatever may be the return that will be displayed. Here GCD or HCF for which number you wanted, any number of your lines we can give. GCD of 36 and 3. This is the method and this is the method. Like this, we can give different sets of value. GCD or HCF of what is called as with the help of object, send some few values. What value do you want to give it? Let's say that 77 or 77 to 11. Boys and girls, one thing you need to know. You need to know there has to be an exit of a function called as, this is called as recursive function, right? Most crucial statement is recursive function. If you don't have the condition, this will be executing over and again. There has to be an exit condition. If q value is 0, come out of this. Come out of this. So this is called as a recursive statement. It's called as a, so a function invokes or calls by itself is known as a recursive function. How long you are going to do? You are going to do for a finite number of times. Finite number of times means how many times? So in this case, it will execute for till the Q value attains 0. Otherwise, it will be doing the job over and again. If you do not have an exit function, you add it. Where recursive will be executed for infinite number of times. You will never ever come out of your program. Two things has to be kept in mind. What is the first one is? You have to have invoking the recursive function, and the recursive function should have an exit condition so that it comes out of the program. It goes to the program where it is called from, and it will give the desired output, right? This has to be thought about. As I told you in the previous program, we will be doing another 4 to 6 programs, right? What are they? Figure to word conversion, decimal to binary, decimal to octal, decimal to hexadecimal. Okay, we will also do some Fibonacci series, right? Please pause this video, copy down this program. These are all the solved examples you may find even in your textbook. Some mild changes are there for our convenience. We have changed it. Okay, kindly do practice, boys and girls. Take care. Bye bye.